Okay, last but not least, we have factors and polynomials. So this is maybe something that you've done before, maybe something you remember from Algebra 1, but maybe not, and that's okay. We're going to talk about it right now. So if I am going to factor, I always want to look for that GCF first. And then after I maybe pull a GCF out, if I still have 4 terms inside my parentheses, then I want to be thinking about how should I factor that polynomial. And there's kind of 2 ways that I like to do it. One way that I kind of like to think about doing it is undoing the box. So like sometimes when I'm boiling stuff, I use that box where I put the numbers on the outside of the box and then I multiply each of the inside boxes. So instead of doing that, I put all of the 4 terms inside a box and then I kind of undistribute out. A shortcut way of doing it is by grouping. So I'll kind of show you both. They're kind of the same, just like this is an organized way of doing it, and this is a little like maybe faster because I don't draw a box, but they're really sort of the same. So let's just dive right in. Let's grab our factoring 4-term polynomials. So look at that. This one's going to be easy. Always want to look for that GCF first. I don't like that this is not in standard form. Let me rewrite. We should be in standard form, I feel like, always. Minus 7x squared plus 3x minus 21. And it does not seem that they have a GCF, okay? So the way you can do it with a box is instead of putting the numbers on the outside, like we normally would, these are the numbers that were on the inside. So starting in the top left, we're going to do x to the 3rd, and then we're going to move over and then come down and fill in each square. And then you just sort of undistribute each square. So like looking at these 2, I notice that they have an x squared in common. Actually, I'm going to do this in a different color. So these 2 have an x squared in common. Looking down here, these 2 have a 3 in common. So that was kind of going this way on those. Then we kind of need to factor up. And so like looking at these 2, they have an x in common. And then looking at these 2, they have a -7 in common. Now, once I think I've sort of solved my puzzle, I can always know that I'm right because I can multiply it back. So like x squared times x gets me x to the 3rd. -7 times x squared is -7x squared. X times 3 is 3x. And then -7 times 3 is -21. So it all works back out. And so that means these outside numbers is how I factor it. So at the top, we have one factor of x minus 7. And at the side, you have x squared plus 3. Now this one might not be done, but since it's a square, it'd have to be a minus sign. So I know I am done. Okay, let's try another. That did seem easy. This one's medium. So again, looking through this, we're not quite in standard form. So I'm going to do that first. So let's be x to the 4th. And then we have -2, -1, so -3x to the 3rd. And then plus 8x. And then a -24. Like if this wasn't able to combine like terms down to 4 terms, then you really wouldn't be able to factor. Like this was too many terms. You can only do it with 4, okay? And so one method we can use is the box. So I would do x to the 4th minus 3x to the 3rd. Sorry, they did not have a GCF, by the way. 8x and -24. And so then we just do rows and columns. So like looking at this row right here, I notice we have an x to the 3rd. Here we have an 8 in common. The negative always freaks me out, but then I notice like here I have negatives that I can take out. So like -3 is going here. So I took care of the negative. And then like here we have an x. And then I always just like to double check to make sure it works back. So x to the 4th, -3x to the 3rd, 8x, and -24. Now I'm going to move this one down a little bit because I want to show you how I do this by grouping as well, just in case you're wondering. Okay, so just our top and then our side terms. So kind of the way we do it by grouping is sort of the same. Like we look at the first two and we look at the last two. So the first two have an x to the 3rd in common. And if I take that out, there's 1 left, and then -3. And then if I look at these two, we have an 8 in common, positive, and so I'd have x -3 left. Whenever you do the by grouping thing, you should then notice that you get twins. And so whatever your twin is, you write it down once, and then whatever's left goes into your other set of parentheses there. So whatever you think is easier, honestly. Sorry, that's a little confusing without color. Let's maybe do that. But something that I did notice when we factored here, these are perfect cubes. So we're going to have to factor this again. So the x -3, I know I'm done because it's linear. It's to the 1st power. But this one, I had a suspicion that it might not be done because it was not to the 1st power. And I noticed that these were perfect cubes. Oh my goodness, perfect cubes. And so we can get a binomial trinomial situation. And so x times x times x is x to the 3rd, and 2 times 2 times 2 is 8. And then I square, multiply, square. Signs go same, different, positive. And then that is your final answer. That was a little harder. That was definitely a step up. That was definitely a medium. So what does that mean for this last one? Okay, we're finally in standard form. Good job, but we have a GCF. So let's take that out. Definitely can take a 2 out because they're all even, and I can take an x out. And so when I do, we'll have x to the 3rd minus 3x squared minus 16x to the 1st, and then plus, oh my goodness, 48. And then I have 4 terms left. So, I mean, me personally, I like to do the box, so I'm going to set up the box. So x to the 3rd minus 3x squared minus 16x, 48. Then I'm looking rows and columns. So this row has an x squared. I'm nervous about the negative, but I'll come back to it. And then at the bottom here, 16 can actually go into 48, so 16. And again, kind of freaked out about the negative, but we'll figure it out. Right here, we need an x in common. And right here, we have a 3 in common. Okay, so when I think this through, I'm going to have to figure out where my negatives go. So like x times x squared is x to the 3rd. But here I need a negative. So maybe I want to put my negative right here, because then that'll make it a -3. Let's just see. I just like to put it on the number rather than the x if I can. So that makes that right. But then when I multiply here, that's not right. So maybe if I make the 16 also negative, because then they'll both be positive. And that actually does work out, because then negative times x, or negative 16 times x is negative 16x. So that's real good. We got it. So 2x is chilling. One factor is x minus 3, and I know that that one's done because it's linear. And then the next one we have is x squared minus 16, and that one's not done because those are perfect squares and a subtraction sign. So we'll go one more time. And we'll get two binomials, 1 plus, 1 minus, x and a 4 in both. I don't know that that was harder. Maybe it was harder because they had a GCF first. I don't know. And maybe because of the weird negative thing, but. All right, polynomials. I like a box. You could do a group if you want. But then after you do all that, you still got to think about, can I factor more? It's going to be my mantra for the next couple of days. But can you factor more? I'll see you in the next one, guys.